So before going further, just a quick question on DevOps. So what is DevOps? Do you have any idea? Anyone from of you? If someone asks you what is DevOps, so
Uh,
what are the things that comes into your mind or something that you know about DevOps?
DevOps is a combination of development and operation things which are deploying the code or go live in a proper way.
Okay, good, good, very good. Any other answers? Very good, Ravi.
Thank you.
Yeah. Any other answers? No. So let me write the theoretical definition first, and then we'll see practically. Okay, how what exactly DevOps is. Okay, I'll write the statements. So DevOps. First of all, if somebody asks you what is DevOps, you should never say it is a combination of tools, or it is a software, or it is a platform. Okay, just remember, it is just a culture. DevOps is a culture of practicing SDLC methodology, software development lifecycle methodology. Sorry for the typos, it's a new machine to me. Okay, just bear with me. Which establish and emphasize the effective communication and just go with the typos right. Collaboration between dev team and ops team. So this was the theoretical definition of DevOps, and some people might have some other definitions as well, but I'll stick to this one. Okay. So by looking this, okay, you can say it's so much of confusion, right? So let me try to understand in detail, okay, from base scratch itself. But don't worry about the definition. I'll try to explain each and every part of the definition. Maybe it will take a couple of days to understand the sentence statement. Okay. Um, yeah. So it's a combination of dev and ops. Somebody said that's good, but who will be there in dev and who will be there in the ops? You need to understand. Okay. I said it's a combination of dev team and ops team. So we need to understand who will be there in the dev team and who will be there in the ops team. And we need to understand a little basic things about a software development lifecycle methodology also. Okay. Suppose, okay, uh, sir, um, so let's say there is a company called XYZ. As Facebook, as an example, I'll take Facebook or something. Okay. So Facebook or some XYZ company. Now, somebody is having some idea in his mind. Okay, so he wants to implement that idea. Okay, but he might not have the technical exposure to implement that. So what he'll do, he will hire some developers who can implement his idea, right? Who can write their code. So obviously the first person who will be taking the requirements, I'm not going into the depth of requirement gathering and other things, just a brief overall idea. Okay, first, the first part is developers will be developing his idea. So they will be writing code by using some programming languages like Java, Python, PHP, whatever it is. Okay. So once they write the application, once they write the code for the application, right? So they need to deploy that application into servers so that end users like us can access the application. Okay. What is a server? We'll talk about it in a separate session. But as of now, everyone might have idea about server, right? What does it do, server? By looking at the name itself, you can see just okay. Bear with this font size. Okay, I don't want to waste time currently. I'll just look into it and I'll let you know because I'm not comfortable with Windows. I'm a basically Linux guy. Okay, so the basic idea is developers would be writing some code. Okay, and the application will be deployed into servers so that end users like we can access the application. How we be accessing application? We'll be entering a browser, we'll be opening a browser and we'll be entering www.facebook.com from the internet, right? Imagine it's the end users. Okay, so is end user and he will be accessing the application via the internet, right? So those who enters www.facebook.com, they will be accessing the application. Okay. So the first thing is developers are responsible to write the code for the application, right? Just look at the screen. Okay. This is the key thing to understand. Mm, let me. So I want to access Facebook application. How will be accessing? Imagine I'm an end user. I'll say facebook.com. Now what I'm getting? Application, right? But developers, what they do? They'll write some code like this, right? Yes or no? So if I deploy the code by taking from the developers and I deploy the code into server, what I'll get? I'll get code only. Yes or no? Developers will be writing the code and if I deploy the code into server, if I want to access, I'll get like code like this only. But how to convert this code which is written by developers into an application so that if people want to access, they can directly access the application, not the code. Getting my point? These were the first thing to remember. Okay, in the DevOps perspective, this is the first thing that we need to remember. Okay, now the first step is how to convert the source code which is written by the developers. Source code means the code which is developed by developers. Okay, so this code I want to convert into an executable. Like I want to convert into, so I don't use that much technical words. Okay, I'll try to put the thing simple. Now I want to convert this code into an application so that I can happily deploy that application into server so that end users can access the application. Okay, now how to convert this source code into an application? This part is technically called as building. What is called? It is called building. What the files font? You want me to select or something? All right. Okay, the space is called as building. Okay, if you take the source code and you build it, what you will get? You will get some, you will get an application, which means some executable. Okay, in technical words, it's called as an artifact. Remember the technical word. What are the technical words that I use? Just you remember. Okay, it is called as artifact, right? And this artifact, which means the application, we need to deploy it into server environment. That's it. As simple as that. Okay. So totally how many teams? Developers' responsibility is to write the code. Now who will be building this application? There is a separate team called as build and release engineers. As of now, I'll just put it as build engineers. Okay. So build engineers' responsibility is to build the source code. And they will generate an artifact, an executable. And who will be deploying that application to server environment? There is a deployment team, server deployment team, who will be taking care and they will be deploying the application to server environment. Clear? Three stages now. The first step is write the code, which is the responsibility of developers. The second step is build the source code to convert into an executable. And the third step is to deploy it into server environment. Okay. Now developers develop the application, build team build the application, and deployment team deploy the application. But is there any guarantee that the application, that whatever application that they have written, the developers write, it will be working fine? Okay, if I click on sign up button, it might not be sign up or it might not be login. There might be some issues. If I order for, suppose it's an e-commerce application, if I order for 10 rupees, they might be generating 100 rupees bill. Bugs would be there, right? So before deploying it to server environment, we should thoroughly test the application. Otherwise, our entire business will be shutting down. So if you try to access an e-commerce application and if you make bill of 100 rupees and you'll get 1000 rupees bill, will you use the application? No, right? So the quality should be good. Yes or no? So before deploying the application into main server, so we will be deploying or we will be sending the application to a testing phase. Okay. So another thing would be testing. So is responsible for testing the application? We'll call test engineers. Okay. So before deploying it, we will be sending that to testing environment. Mhm. Okay, we'll be sending that to testing team. So if testing engineers will thoroughly test the application, okay, if they find no bugs, we'll be deploying that to server environment. Clear? Building, development, building, testing, deployment. It looks very fine, clean and neat, right? If something goes wrong with the testing, they find some bugs, they will be sending the application to developers back again. They will be fixing the issues, and again those issues needs to be again built, right? Again they will be sending back to the build team, sending the application to the build team. The build team will be building the application, and they will be sending to testing, and then the testing team will thoroughly test the application, and they'll be deploying the application into server environment. Good, right? So as a DevOps engineer, okay, before DevOps, okay, I'll not take much time, just try to understand. Okay, before DevOps, these are the things that is actually happening. Once the developers have written the code, okay, they need to send an email to building team. Okay, right? So I'll just try to elaborate a little bit over here. It's not that only one developer will be developing the application. Yes or no? There might be a group of developers. Some people might be in India, some people might be in USA, some people might be in China. Yes or no? Right? It's not a single developer who is responsible to develop the application. Multiple developers are responsible to write the part of the applications. So each developer will be writing some part of the application. Yes or no? Okay. Now, if the build engineer wants to get the application, so from which developer that he needs to get the code? Even he don't know, right, where the developers are. So all these developers, once they write finishing their code, they will be putting their code into one central place or one remote place. You can say one common place as of now. Okay, this is called as source code repository server. Okay, what is this called? Source code repository server. As of now, I'll say source code repository server SCR. Fine, right? Shortcut I'm writing. Okay, sir. Okay. So developers, they'll write the code, they'll upload their code into source code repository server. From there, they'll be sending an email. This developers team manager will be there, right? He'll be sending an email to the building team. Now the building team will be taking the code, and they'll be building the application. Once they build the application, now somebody should be there to deploy this application into testing environment, right? Where will be performing the testing? Testing also done on a server. So there should be a sample server. Yes or no? There should be a server which is purely meant for testing, and they'll deploy this application into this server so that the test engineers will be testing the application. Always remember, test engineers will test the application, not the code. Okay, what is the test engineer's responsibility? The application is working fine or not? If they put like they enter login, it's properly logging in or not? Okay, everything they need to check the functionality. Okay, so testing always comes after the build. Okay, now yes, even test engineers, they'll be sending an application to the deployment team to deploy that into testing environment so that test engineers can logging in. Again, you need to send an email. Hey, testing team, your application is ready into testing environment. You can run your test cases over there. So test engineers would be logging in, and they would be running their test cases. If everything is done, again he needs to send a confirmation to everyone that the application is working fine. We can proceed further to deploy the application into the main server, which is called as live server is called as production server. Okay, this live server is called as production server, where the end users like we and you will be connecting and using the application. Okay, clear? Clear up to now? Sir, do you have any doubts up to here? So I just want to extend a little bit more. Clear, right? As of now?
Yeah, clear.
Clear with the flow? Right.
Yeah.
Okay. And now let's try to understand the complexity here. Okay. So the developers, whoever the developer the code, they might be working in the day shift. Okay, the build engineers, they might be working in the second shift. The test engineers might be working in the morning shift, but the deployment might be working in the night shift, right? So developer developed the application, he just put the application into source code repository. Okay, and afternoon the build team will be logging in. Suppose if they get any doubt, right? So from where we need to pick up, I could not find the location or something about the application. Okay, they'll be sending an email, or if they want to connect, the developers are not available. They might not be available. Okay, right? If the build is failed, there are so many reasons the build might be failed. Okay, for suppose, as of now, I'll just keep the things simple. Okay, this developer has written some functionality, this developer also written some functionality. Okay, for an application, right? Suppose he's responsible for writing the login page code, authentication and authorization. He might be responsible for implementing a product card, or suppose we are talking about Facebook, right? So I'm not a big social media fan, so uploading images or something. Okay, he might, some other developer is responsibility for live feeding or something. Okay, so we are not sure that this code is compatible with this code. Okay, there might be a compatibility issues. Okay, if you come try to build all these three things, the build might get failed because of the inconsistency or something. Okay, this developer might be written a same function or same function name, here might also use the same function name, right? There is no guarantee that they can use the same function because they are working in Xylos. They might be using the same function name, or they might be using some incompatible versions of their Java or something, some dependencies. Okay, in order to develop the application, they'll use some kind of software. This developer is having a different version in his laptop. This developer is having some different version of his laptop. Okay, both the code might not be compatible. So build engineers will be the outcome. Definitely the build will get failed. Again, if you want to connect, these developers might not be available at that time. Even we need to wait until the developers come. So we'll be just raising a bug, writing an email, and then throwing back again. Imagine it's also done fine. Okay, the build is successfully built. Okay, now the deployment team deployed into testing environment, into the testing server. Okay, now what happens if the test fails? So the test cases might be failed, right? They might find the same bugs, some bugs. Okay, again they will be throwing back the application to the developers by saying these are the bugs, list of bugs. Okay, now the developers will be saying, hey, my part of the application is working in my laptop, my part of the application is working in my laptop. Everybody, nobody will be taking the responsibility of the error, right? Yes or no? Again the same fighting. So developers will be saying my part of the application is working fine, my part of the application is working fine. So before sending the application, even they need to verify the integration part of all this code, this all the developers is working perfectly fine or not. Yes or no? So for this also they require a server, so that even they can check from the developers environment. Okay, now one more server. What is the server? Now we call it as a dev server. So what is the purpose of the dev server? Developers will be checking their code, right? So they will be writing the code if they want to test the application whether it is working fine or not in the, okay, from their perspective, even they require a dev server. Okay, so all the developers will be writing the code, they'll be uploading the code to source code repository. From there they'll be sending a build email to build team. Build team will be building the application. The deployment team first now deploy the server, the application into dev server, and he'll say, hey, I deployed the application into dev servers. Now go ahead and verify for whatever the functionality that you have written the code, right, whether the same thing is getting reflected in the application or not. Okay, if they find any bugs with their incompatibility or with other developers code, they can go ahead and verify here itself, and they can fix it. Again they'll send a mail to build team. Again build team will build the new build. Again they will be sending to dev server so that developers can log in and they can verify, right? Yes or no? Once they said developers, okay, the application is working fine in our dev environment, now they will give the confirmation that you can proceed for deploying it, or you can proceed to send it to the testing environment. Again the build team, they need to deploy to testing environment. Again you need to send an email. Testing team will be coming same side cycle, right? Okay, now if they get stuck at some point, okay, let's say the application is working fine in dev environment, the same application deployed to testing environment might not be working fine over here. Yes, developer will say, The application is working fine from our end. We checked in dev servers as well. Previously, we don't have dev servers. That's why you are criticizing us. Now the application is working fine in dev environment. We have verified that. But on testing, it is not working fine. Okay. Always fight between the dev team and testing team. Now, who is going to resolve the issue? Somebody could be coming pitching in and they will be logging in and they should troubleshoot, right? Okay. So, on the other hand, the operational team, okay, these guys will be fighting and they'll be raising a ticket by saying that, hey, the application is not working fine. Somebody could, from the operations team, look at troubleshoot the errors and let us know. We have done the basic troubleshooting, but we don't find any errors on dev environment. But testing team is finding errors. Okay, so operational guy might be working in night shift. Okay, he will be logging in and he will be verifying from the basic stuff itself. Okay, he identified that. Okay, on dev servers they have the Java latest version, Java 17 as an example. I'm saying. Okay, so JDK 17. JDK means Java Development Kit. JDK 17. On testing environment, they are having JDK 11. That's why application is not working fine. Wait a minute, I'm going to upgrade this. So he'll be upgrading this, and again he'll be going back to his routine duty. Okay, I'm not talking about operation anymore now as of now. So he'll be maintaining the servers, he'll be doing some patching, he'll be installing the packages, doing something. Okay, so he'll be update this one and he will go back to his routine work. So application started working fine over here. Now again, the same application is deployed into production. All of a sudden, on production server, the application is not working fine. Okay, the person from the operation team who has identified the bug, he might not be informing to everyone because he is doing his regular work. He just troubleshooted and went off. Okay, meanwhile, he might be leaving the company or he might not be available at the time, he might be on leave. So, what happens? Obviously, the production deployment to server is getting delayed. So, if I develop some application, if the application is on live, then only I can earn some money. Otherwise, people are not using it, or if we don't deploy the application into server, then obviously I will not get any revenue, right? So the idea is from the development to the deployment, this phase should be shorter so that I can get some revenue quickly, as quick as possible. So before DevOps, you need to connect each and every one individually. But with DevOps, what they said is right from the development to the deployment, whatever the stuff is in between, what are the cycles are there, right? So we need to automate the entire process. Okay. The first step is we need to automate this entire life cycle, which we technically it is called as CI/CD. Remember this word. Without this word, there is no DevOps. CI/CD means continuous integration and continuous deployment. This is what the first main major responsibility of any DevOps engineer. Okay, sir, clear up to here, everyone? How to automate? We'll see. No need to worry. Practically, we are going to do this. Okay, it's not that simply I'm drawing the picture and I'm explaining you. Sir, clear, everyone? Up to here. The first
Yes,
major
sir.
responsibility of DevOps engineer, right from the so we don't need to develop the application. Developers will be developing the application. Okay, once they put the source code, once they upload the code to source code repository, from there, whatever the flow, we need to automate. It's called CI/CD. I hope it's clear for everyone as of now.
Yes, sir.
Yes, no more complications. I'm just trying to keep the thing simple. And now, let me take a new one. Now we'll try to understand in different perspective. Now we have seen some server environments, some servers, right? What are the servers? Please. First of all, we have seen the prod server, right? Production server, where end user will be connecting and they'll be accessing the application, right? I'll say production. I think I need to fix the font size, I guess.
Sandeep, this production server will come at the last, no? I mean,
Which one?
before the end user accessing the application, for example, Facebook or something, prior to that only this production server will come into picture, no? Just the before step of end user accessing the application.
End user will be accessing the application which you put in production server.
Yeah, that is what I mean.
Yes,
This should
yes,
be the
yes.
final
Once you
step which
deploy the
I'm
application into production server, then only the end users will be accessing.
okay, yeah, got it.
Yeah, right. Yes, you are right. Okay, very good.
Yeah.
Okay, now we have seen dev server as well, development server where developers even they'll be checking from their end, right? Dev server. Let's say, and we have seen testing server, right? I'll try to fix this. Okay, I'll name as a QA. Okay, quality assurance, QA testing servers, whatever you name it. Okay, and yeah, so we're talking about server environments. Hmm. So you know the purpose of each thing, right? So developers will be connecting to the dev servers. They'll be testing their application from the developers' perspective. Test engineers will be testing their application. Okay. Now apart from that, we'll be having one more server called as build server. I'm not writing it. Okay. If you want, you can make that one as build server. Okay. Test engineers will be thoroughly testing the application. Now imagine a situation where I'm the product owner. Okay, I have given this project to TCS. Okay, so imagine TCS. So TCS guys have developed the application. Their developers written the application. TCS guys they have tested the application. They are saying it is absolutely working fine. And all of a sudden they have deployed the application into servers production environment. That is same TCS guys. Okay, but the end users are facing so many errors. So as a product owner, who will be facing the charge? Who will be facing the loss? I'm facing the loss, right? Yes or no? So they have developed the application. They have tested the application. They are assuring me that the application is working fine. Topu turumu, this is the application. Okay, application is awesome. Okay, it will be a trend buster, chat buster, something. Okay, and they have given me so much hype. All of a sudden, they have deployed to the production. They might have facing some runtime issues. They might be having facing so many bugs, right? So obviously, I will be facing the loss. So instead of believing one guys, now what I'll do, I'll say, okay, I will put a testing team from my end. Okay, I will maintain a testing team from my end, and once the testing is the application is working fine, so they need to deploy the application to they need to hand over the application to my testing team. Okay, now even my testing team, if the guys said if everything is working fine, then only I'll allow them to deploy the application to production. Okay, this is called client side testing. As of now, you can call it as UAT, user acceptance testing. Okay, this project I'll give it to some other company like Cognizant. Okay, so development and testing will be done by TCS guys, and client side testing will be done by Cognizant. Always they will be fighting, right? So if these Cognizant guys can raise bugs, they will be actively working on it. Okay, if they find so many bugs, they might not know that the same development project might be coming to that their company. This is how companies work, right? So until my testing team said it is working fine, then only I will give the permission to deploy that feature into production, right? So it is called UAT. It is also on server environments, user acceptance test. Okay, I'll say as of now UAT. I'll put as UAT. Okay, apart from this, so many other environments as well, but I want to just keep it short as of now. Okay, right? So now let's try to understand this thing. Okay. Hmm. So these many servers. Who will be maintaining these servers? Who need to maintain these servers?
Operation team.
Operations team. Okay. So they need to log into. They need to verify the health conditions. All the servers are up or not. Okay. They need to take the backups. They need to check the network connections. Okay. They will need to check the so much they'll be putting some kind of observability, maybe to say they want to check the health conditions, how the applications are working on it, is there anything down, all the services are up or not. But I don't want to speak all those things, but as of now, okay, I'm not going to that much detail to the operation, but I just want to keep it cut short. Okay. Okay,
Sandeep,
now the application is deployed into production. We'll see the runtime issues once we are into practicals. Just imagine, okay, so my application has been, after so much of struggle, my application has been deployed into production. Done. Now on production, my imagination is okay. If I deploy this application into live environment, okay, some 2,000 users will be using the application within a 10 minutes or some time frame. That is what my idea. With that intention, I have taken a server with high configuration and I have deployed the application into server. But unfortunately, so many these people liked my application. Even they try to give some positive feedback, and even they will be telling their friends, they'll be informing their friends that this application is very good, try to use it. So my imagination is for 5 minutes 2,000 will be hitting, but all of a sudden 4,000 people started using my application. It means 4,000 requests are coming to my server. Okay, so my server can't able to build the load, but it can't able to take the load, right? So all of a sudden server will be first slowing down and then totally it get crash. Yes or no? Suppose your capacity is to, if I given a 10 kgs of stone to you and I just ask you to run, you will run fast, right? If I put some 20 kgs on you, you'll walk little slow. If I put 50 kgs, you may not run, but you can walk. But if I put 100 kgs, even you cannot move. The same thing with server also, right? It can able to handle 2,000 requests, it will run. When it comes to 2,500, little bit slow. 3,000, it will slowly walk. Which means if you try to open facebook.com after rotating for 5 minutes, the application will get open. If the application is too much slow, then who will use the application? Obviously, negative review will go to the market. Yes or no? Then, how to overcome this issue? How we can overcome this issue? 4,000 users are now hitting my application. My server is down, right? Now, if I give you to 50 kgs or 60 kgs, if you can take from your friend, then if you two people are carrying the same weight, then you can run, right? If I give you 20 kgs, previously the performance little slow, now you can run. Even if I give 30 kgs, you both people can take it. If I put 50 kgs, you both people can able to take the load. Okay. If I put 100 kgs, if you two persons are not enough to take the load, you'll be taking help of some other guy. If you three people can start running, yes or no? The same idea. If single server is not able to process all the requests, now what I'll do? Previously one server is there. I'll add one more server so that now 4,000 users it can handle. Okay, the traffic is too much increasing. Again, I'll add one more server. What is the issue? Okay, if the tracking is too high, imagine my product is going up, it's hit the bullseye. Okay, what? No problem. I'll start keep on adding the servers. Previously, one single server is serving my application. Now a group of servers are serving my application. It's simply called as a cluster. In technical words, you just need to remember cluster. Cluster means a group of CPUs acting as a single machine. Okay, but as of now, just try to understand. If a single server is not serving the application, I'll keep on adding the servers so that group of servers can handle the requests. Now, imagine here's the situation comes. Okay, I have started with one server. Now, if I want to add one more server, how much time it will take? That's what my question. Okay, people started hitting my application. The application is getting slow. Now I started going to purchase a new hardware machine. Okay, in software companies for that you need to get so many approvals. Why you need this? What is the hard disk size? Why you need this much of RAM size? You need to define all those things. Okay, from their approvals, you need to go to the vendor. From there, we need to purchase it. We need to get it, and then we need to fix to the network, and then we need to install the operating system. We need to install all the software which are required, and we need to deploy the application into your new server. This much, so much of process is there, right? If it is a physical server, it will take minimum 15 to 20 days. But in real time, can I wait for 15 to 20 days? Okay, after 2,000, 3,000 persons came to access my application, I'll say wait for 15 days, we are going to resolve. It's not the thing, right? So that's why what we are doing is we are taking the help of cloud. We are not maintaining the servers physically, we are taking the help of cloud like AWS. What is cloud? We'll see later. Practical, like how we have discussed, right? The same way. For AWS, Azure, GCP. Okay, simply what they'll do, they'll be having their servers and they'll be giving their servers for rent to us. That's it. Okay, they're having their servers, they'll be giving their servers for rent. Okay, if I want, I can go ahead and happily take the server from them. Okay, it is on cloud. I'll take the server, but in order to get the servers, it will take minimum of 15 minutes of time, which is good, right? Within 15 minutes. Previously, it is taking 15 days. Now it has reduced to 15 minutes. I'll just contact them. I'll just go ahead and I'll say, I want one server with this capacity. I want this. Immediately, they'll give within 10 to 15 minutes. The work will be done. Right? Now, try to understand the situation. Why we need to go for cloud? Okay. So even I purchased my servers. So all my hardware is ready. Okay. I'm just keep on adding the servers physically. It went to like 200 or 300 servers I purchased according to my requirement. I make it everything ready. Okay. Understand the situation? Purchasing a server, attaching it. Purchasing a server, attaching it. But all of a sudden, after 30 days, okay, people lost interest in my application. Then slowly the traffic is getting decreased. Yes or no? So I purchased 200 servers. After 30 days or 60 days, slowly the traffic is getting decreased and it went to 100 or 200. Now, why I need to maintain these many servers? I purchased them, right? But investing crores of rupees. All of a sudden, all these things are useless. Yes or no? Understand the situation? Yes. That's why if you go for the cloud, what they are saying is, as of now, I'll give you just a brief idea. So if you want a server for some time, you can take it for some time. If you want for one day, one day. After one day, if you want, you can return it. If you want for 30 days, you can take it for 30 days. After 30 days, you can return it. Only 30 days bill you need to pay. This idea is good or not? That's why cloud has become so popular. So they'll be taking the server within 15 minutes, they'll be attaching the server. It's not good. Again, within 15 minutes, they'll taking the server. Yes or no? So group of the servers will be serving application, all happy. Okay, mother child both are happy. But imagine this real time situation now. Okay, suppose Amazon is announcing some flash sale. Amazon or Flipkart, Mintra, 30 minutes or 1 hour, 30 minutes something, right? Flash sale. Okay, so they might not know how much traffic they'll get. Okay, even to create a new server from cloud, it is taking 15 minutes. Means if the traffic is too much high, too much heavy, okay, I need to wait for 15 minutes to come. Within 15 minutes, the offer itself will get closed. Na? The offer will close, again the server will get crashed. So I need to make less time to provision a server. Okay, it's called zero downtime. I want. Okay, it means for now I need a less time to bring up a new server. Okay, so that is what we are going to do in future. Okay, all these things will be slowly doing it, but as of now the first responsibility is CI/CD. The second thing is provisioning of servers, creating a new service, provisioning of servers. Okay, if I try to provision these servers manually, it will take 15 minutes of time from cloud. Imagine that I have gone to cloud and I have taken the server, and if I try to fix it, it will take 15 minutes of time. Okay, so I don't want to waste this just 15 minutes of time. I want to put them on the fly. Okay, I want to automate the process. If the traffic is too heavy, according to the traffic, I want to add a new server within less time. This is what is called as infrastructure as code. What I'll be doing is, within infrastructure as code, I'll be writing a script. Okay, within the script I'll mention, whenever the traffic reaches to this, I want this much hard disk, this much RAM, okay, this much CPU. With this operating system, I want a server with these features. I'll write a script. Okay, I'll put the count as 1. If it reach, I'll just run the script, one server will come. If I want 4, I'll just modify the count as 4, and if I run the script, 4 servers will get created from the cloud itself for me. Okay, which we call it as infrastructure as code. This is what the second responsibility of a DevOps engineer. We want to automate the process of creating the servers on the fly. This is what infrastructure as code. Once I have got all the servers done, but these servers should run with some kind of services, right? Suppose they are running Tomcat, I want to run Tomcat. They want some port number of Tomcat. I want to change the port number. I want to put some custom configurations. Okay, I want to allow SSH traffic. So many configuration should be done. If it's not that directly blindly I'll take the server and I'll deploy my application. It's not like that, right? So on that server I need to configure something. Yes or no? I'll purchase a new TV. That doesn't mean that I can watch anything, right? You have to connect with the Wi-Fi to watch a channel, or you need to purchase the dish, right? So some configuration is required, login button or something. All these configurations are required. Yes or no? So that configurations, if I start doing those configurations manually, I log into the server happily and I'll say by having a coffee, I'll install Java. I'll take the requirement. Okay. I'll start Tomcat. I'll run Tomcat on this machine, this port. Okay. If I start doing it manually, how much time again it will take? So much of time. You added 4 servers on the fly by using infrastructure as code. But on the 4 servers, if you want to do the configurations, if you try to log in them manually and doing the task, again it will take some time. So much time actually. Okay, if I do two things, okay, 2 servers done. On the third server, okay, I started doing the list of tasks. Okay, by doing the second task, my girlfriend called me. By talking to her, third or fourth step are gone. Okay, my application will behave same as in these 2 servers, but it will behave abnormally in this machine, even into troubleshoot. For that troubleshooting, again it will take some time. So all is a waste of time, right? So for this, not to overcome, what I'll do, okay, after creating the server, I'll write a script file. Okay, within the script file, I'll mention what are the configurations that are required, which version, which service should get started, and which port number it is to run. Everything I'll mention in this script file. I'll mention the code and I'll run the script. Once the servers are ready, I'll run the script file in all the servers so that whatever the configurations that we mentioned, the same thing will be available on all the servers. Yes or no? Right? This is what the thought responsibility of any DevOps engineer, which we used to call it as configuration management. Okay, now let's try to put them all in one order. First thing, I want to create 10 servers. How I will be creating? By writing a code, which is called as infrastructure as code. Now, can I make it as number one? The first responsibility. Once all the servers are ready, I want to do the configuration management. I want to configure all the 100 servers. Now, this is step number 2. Once all servers are ready with the required configurations, okay, now my application should be there on all the servers. Otherwise, no issue, no use, right? Yes or no? If all my servers are ready with the required configuration, my application, someone has to deploy the application. Okay, that too they want to deploy it to 100 applications, 100 servers. Okay, for that also I write a script. I'll run that script so that all 100 servers will be having that application. Okay, the entire process, I said CI/CD right from the development, whatever the changes that he'll do, go to building, testing, UAT, client side testing, and then production. Right? So I'll make this as number 3, CI/CD, continuous integration and continuous deployment. So these 3 are the major responsibilities of any DevOps engineer. Apart from that, you won't be doing anything. Okay, first thing, infrastructure as code, creation of creation of the servers, or the automation of creation of servers. Next, configuration management, configuring all the servers in automatic way. Next, CI/CD, deploying the application in automated right from the development to the deployment. These 3 are the major responsibilities. Now, how we can achieve this CI/CD? I said, right, developer would be having some different version. Testing might be having different version. Okay, he might be working on different shift, team is working on different shift. So each and every team is doing their individual works. With DevOps, what they said is stop doing it individually. Everybody form as a team and then start doing it. Why? So that they'll be having a communication between them. The operation guy which you found, right, he just updated Java and he just went off. It's not like that. Now he updated. It has to be. He is the accountability of that one. He has to be informed everyone in the team so that everyone should know what exactly the issue and how he has resolved the issue. Okay, so that's how you can make the application continuous integration and continuous development. You can make the application right from the development to the deployment faster so that the client, which means the product owner, will be getting some revenue out of it. Okay, so previously everybody working in silos, now everybody formed as a team and they will be communicating with each other. That's why DevOps is called as a culture which establishes the effective communication and collaboration between dev team and ops team. Okay, tomorrow we'll see why it is called as a culture and why the communication between dev team and ops team is important, and who will be there in the dev team and who will be there in the ops team. Okay, and that is done. We'll be discussing more about servers because we are going to work with servers. As you understood, right? What are our responsibilities? Creation of the servers. First, manually we will create, and then we'll try to automate the process as we should do. Next thing, once servers are ready, manually we will be configuring the machines, and then we'll be doing the automation of that. And third thing, we need to make the application deploy to the CI/CD process, right? So for this, if you want, yeah. So entire thing is practical over here. Okay. So if you want to practice this, we need to have a cloud account. I'll prefer AWS. If you want anything, you can go ahead with that. If you want Azure, you can take Azure. If you want GCP, you can take GCP. But for my course, I'll prefer AWS Cloud. So better you guys go ahead and create one account on AWS Cloud. Okay, they'll charge 2 rupees. They'll give you free for 1 year. Some of the services are chargeable. I'll tell you in future. But as of now, you can go ahead and create your account on AWS Cloud. aws.amazon.com is the official website. No need to be hurry. Just if you have time, just go ahead and create your account. aws.amazon.com. Don't ask me how to create this account. Okay, you are a DevOps engineer and you know how to open account in Instagram, Facebook, right? Likewise, create an AWS account. It will ask you your mail ID. It will ask you to set the password. Okay, some details about your banking debit card. Okay, they'll charge 2 rupees. Within 24 hours, again, they'll credit your 2 rupees back to your bank account. Okay, so no need to be in hurry, but tomorrow or day after tomorrow, I'll start the practice. Not tomorrow, after a couple of days. Hopefully, from Monday itself, we'll start creating the servers manually. That's what the first task. Okay. Uh, any doubts till so far? So there are a lot of things to cover. So I'm going step by step. Hope you can understand. Okay. I know I have injected so many stuff for today, but it's required because the syllabus is very huge. It's not that hurry burry we'll be doing. We'll be slowly increasing our pace. Okay. Any doubts?
Uh, Sandeep sir,
Yes, yes, yes. Any doubt? Yeah. Go ahead, Mohit. Go ahead.
Ravi Kumar from here.
Ravi Kumar.
Uh,
Okay, Ravi. Yeah.
yeah, actually, I'm working in TCS. I'm having 11 plus years of experience there.
Just wait. I'll stop the recording. Okay.
Okay, sure.
And then
Sorry.
we'll discuss it offline. Okay. I'll start
Sure,
the recording. I'll just stop the recording.
sure.
Guys, anything to add to the current recording? Uh, Nothing from my end. Okay, what are the tools that we'll be discussing or the tools that we are learning? Ravi, just hold on a second. Okay, I'll just
Sure.
give you the overview of the tools. Not overview, just I'll give the names and we'll be discussing about those tools tomorrow. Okay, the first thing is you should know Linux. I'll be teaching you Linux, no need to worry. And we'll be learning AWS Cloud, and we'll be learning. I'm not writing in line, but these are the tools that we are learning. And we'll be learning Git as source code repository, and we'll be learning Maven as a build tool. Okay, and we'll be learning Jenkins as a CI/CD, and we'll be learning Ansible as a configuration management. Okay, with Ansible also we can create the servers, and we'll be learning Docker containerization. There's a different part again, Kubernetes, and we'll be learning Terraform. Okay, and if time permits, I'll take some sessions on Prometheus, Grafana, and how to collect the logs. Promptel is there, and so much we'll be talking about virtualization, how I'm managing my data centers, how the networking configurations. Okay, even networking is very very important. Don't worry, everything you'll get right from the scratch self to the advanced level. Okay, I'll try to put my all my experience to explain you guys. Okay, right? Even in my office also I'm trying to I'm conducting the sessions like this only, right?
Uh,
Yeah, just
Sir,
let me
actually, one
stop the
small
recording
doubt.
here and we'll go with the questions. So
Yeah,
some personal
hi,
questions,
Sandeep.
that's I don't want to include them in the recording sessions.